Okay, in this video we're going to solve this modulus problem. Modulus of 3 minus 2x equals 7 plus x. And we're going to use this really wonky graph that I've drawn. So, looking at this first, y equals the modulus of 3 minus 2x. We were given this to start off with in the question. First thing to think when we have a modulus graph is what are our key points? So where we meet either axis, these are really important to us, and we can solve them by thinking, for this point, we want y equals 0. Let's figure out when y equals 0, what about x? So we have got 0 equals the modulus of 3 minus 2x. And the only way that this can be true is if what's inside the modulus is also 0. So actually we can forget about the modulus itself and just say that 3 minus 2x has to be 0. So at this point 2x has to be 3, x has to be 3 over 2. So we found one key point. Let's mark this on here. X equals 3 over 2. This point is really, really important to us because actually it divides the graph into two distinct regions. One of these regions is where we have y equals 3 minus 2x. That's this region over here. This was where the graph was originally positive, so we can actually ignore the modulus sign. Let's write that in. Y equals 3 minus 2x. And over this side, well, this is where our line would have gone negative, so the modulus has flipped it upside down. That means the equation we've got over in this region, we can call this one region number 1, and this one over here is region number 2. In region number 2, we've got the minus version of this, the negative version of this. So here y equals 2x minus 3 would be the equation of this line. At the moment then, we've got the equation of this line in both of these regions. But what we'd like to do is think about our other line, 7 plus x. Well, writing y equals 7 plus x, we can sketch this thing pretty quickly. It's definitely got a y-intercept of 7 and a gradient of 1. So if we were to mark on here, this is going to be 7 up here somewhere, because this point I forgot to mention earlier, this is definitely just 3. Because for either one of these lines, y equals modulus of 3 minus 2x, if you set x equals 0, we have the modulus of 3, that's 3, or you could also see it from here. 7 somewhere up there then, and because this line was quite steep, it's got a gradient of 2, our line with a gradient of 1 is going to look quite a bit less steep, a bit more of a shallow gradient, something like this. So this new line is y equals 7 plus x. And we can see we've got two solutions for where these two graphs bump into each other. One of them is here, and one of them is here. Significantly for us, one of them is in region number 1, where we have y equals 3 minus 2x. The other one is in region number 2, where we have y equals 2x minus 3. So one of them lies in each part of where we see the modulus function acting. Let's solve for region number 1 first. And what that means in region number 1 is that we make the two y's equal to each other. So 3 take away 2x equals 7 plus x. 7 plus x. And if we solve it from here, well, we can move these two x's over to this side. So we add 2x on both sides to get 3x. And over here we need to take away 7 from both sides. So I will end up with 3x equals minus 4. And now dividing by 3, we should get minus 4/3 is our x. So we found x is minus 4/3. Does that make sense to us? Well, yeah, because over here, x has to be negative, doesn't it? Minus 4/3 sounds good. Just to make it a complete point, we should also find y. So if we know that x is minus 4/3, y has to be x plus 7. So 7 plus minus 4/3. What's that going to give us? 7 would be 21/3. 7 minus 4/3. 7 would be 21/3. 21 take away 4 is 17. So we should have y as 17/3. So to mark these 2 points, or these 2 coordinates on our graph, this would give us the solution. I can put it over here. So we've got minus 4/3 and 17/3. That's one of our solutions. Let's also try and find the other one. Well, that was in region number 1 that we've just solved for. So now if we look for region number 2, this is where we have flipped our function, or the modulus has flipped our function for us. So here we've got y equals 2x minus 3. And that is still equal to our 7 plus x from earlier. So we need to do a really similar thing to find the value of x. That'll mean us taking away, first of all, an x from each side. So to get x equals, we need to add 3 on both sides. So x here we think is 10. And by the exact same thing earlier, well, if x is 10 and we know it lies on the line y equals 7 plus x, we can just add 7 to find y. So y equals 10 plus 7 to get 17. So that would tell us our other coordinate that we were looking for was 10, 17. We found our 2 points where our lines intersect thanks to the modulus function, one of them in each part of our graph.